Hello and welcome to my favorite tutorial. Beautiful, unique, and easy. Actually, I asked you whether to make a tutorial about this or not. I had a promotional video for it. Anyway, now I decided to do this. Today, I will try to do all the things you see now. Of course with sound effects. Yes, let's get started. The hero of this animation is a null object called finger. We'll just use this and get everything done. I restricted this on the z-axis. It should only move between the given numbers. Yes. Now let's just focus on the trigger. The pivot point should be as you see it so that the trigger movement looks natural. We only want the trigger to rotate in the p-axis. This can be between 0 and 40 degrees. I had prepared an Xpresso before. Now let's start filling this in. While the finger object moves between 25 and 55 on the z-axis, the trigger should rotate between 0 and 40 degrees on the p. For this, let's make the following settings in the range mapper. If the connections and settings are correct, the trigger moves. Beautiful. Now let's make adjustments for the hammer. Let's find a good pivot point for hammer, and rotate it on P, between 0 and -45 degrees. We can duplicate the range mapper and change the values. It works fine. However, it follows the trigger back and forth. The hammer should strike when the trigger reaches its lowest position. In this case, we need to add something between the existing connections. We will use two compare nodes. One when the trigger is at the highest position, the other when it is at the lowest position. Higher position must be equals to 25. And lower one must be equals to 55. Let's call it as set when the trigger is in the highest position, and let's call the other one as firing. Now two flip-flop switches are required. One for when the trigger is set and the other for firing. If the necessary condition is met, the switches should turn on. Otherwise it should be off. If one is on, the other must be off. Let's make these cross connections. Now, let's put a condition node to perform the hammer strike. We will only use the trigger set connection. There are two slots here. If the set switch is on, input 3 will active and will ask for a value here. Input 2 will active if the trigger set is 0. The input 3 value should follow the movement of the trigger until the trigger moves from the set to the firing. That's why we transfer the finger object's movement here. In case of firing, we must give a constant value for input 2 until the trigger is set again. In this case, the trigger must be in neutral until it is set. There's a good reason why we put the number 25 here. "25 is the input lower value for the range mapper, and the number it produces for output upper is 0. As long as this remains constant at 25, the hammer will not move and the trigger will be empty. Wonderful! The trigger will not work until it is set again. That's what we wanted. Now it's time for the movements of the cylinder. This section contains very important operations. I left one bullet in the cylinder to see the rotation clearly. The cylinder must rotate on B, in a positive direction at 45-degree angles. We have 8 bullets and 360 divided by 8, is 45 degrees. We will use the range mapper values we used for hammer before. Only the values will be different. The hammer will always produce values between 0 and -45 degrees. We will use this as input lower and input upper in the new range mapper. However, we need to convert the negative value to positive. We will use negate node for this. The input values will always be between 0 to 45 because of the hammer. But output values will change by increasing by 45 degrees. There is a small problem. Range mapper input range must be degrees. Now we will change it and set the numbers again. It works, but each time, the cylinder returns to its previous position. Because we haven't yet added 45 degrees of rotation on each trigger. While output lower increases in 45-degree intervals, output upper should be 45 degrees more than this value. Now, let's open the output ports and prepare the values that will come there after the necessary operations. We will get the value from the firing switch, to find the numbers to be entered here. This number should increase with each firing. We will use a monoflop node for this. The monoflop switch will be triggered with each firing. The number of triggers will increase by 1 each time. We can get this from the count port. Now, let's connect them together and read the results. As can be seen, the number increases with each firing. This number does not reset when I rewind the animation. It should definitely be 0 on every restart. We should connect this reset checkbox to somewhere. If timeline value is equal to 0, we can reset the monoflop node. Let's do this. As you can see, the increased value is reset at the beginning of the timeline. Now it's time for the 45-degree increments. We will do this in an easy and practical way. Now let's add a math node. And let's set this to multiplication. When we multiply the value from the monoflop by 45, we get multiples of 45. We take another math node, but we set it as add. If we add 45 to the number from multiplication, we get increments of 45 degrees. Now let's connect a result node to each of them, and try to read the results. Multiplication and addition values should be 45 in both. Now let's start the animation and check the increments. If you look at the outputs, you will see that the numbers increase with each firing, and the 45 value range is maintained. Now we can transfer them to range mapper. But our input value is degrees. So we need to convert these values. For this we will use the degree node. Cinema 4D works with radians. We will first need to convert degrees to radians. Don't get confused. Degrees or radians, they all actually work the same. We use whatever cinema wants. When we rewind and restart the animation, you can see that the cylinder is making the correct rotations. Now, it's time to fire some shots. We have 8 bullets in the cylinder. I gave rigid body tags to make them dynamic. Now let's look at some values. I gave a negative value to the z direction of the initial linear velocity. The bullets will travel in the -z direction. The dynamics will be on and off, depending on the situation. Friction and bounce values are up to you. I gave the bullets a high custom velocity so they would be heavier. The values you see here are for the bullets to fly more smoothly and not tumble too much. Dynamics do not work when bullets are disabled. In this case, we will enable each bullet in its turn and fire it. First, we need to put each bullet into the Xpresso. But do not accidentally put the bullet objects. We will put their rigid body tags. Now, use the enable slots of every bullet. We will use a very simple Python code to do some calculations. Delete all ports of Python and create an integer port for input. Call it bullet. Then add 8 Boolean ports for output, and name them from B1 to B8. Open the Python editor and write these codes in it. First, all output ports should be in the global line. B1 to B8. Separate them with commas. If this value is greater than 0, it means the trigger is pulled. Whatever the bullet value is, we should assign 1 to the current B variable. For example, if the bullet has an input value 1, then B1 is set to 1. If the bullet has 2, B2 must be set to 1. The same process applies for 8 bullets. When the bullet value is 0, we should set all B variables to 0 with the else method. This can either happen at the beginning of the animation or if no firing has been done. As you know, if these values are 0, the dynamics will not be enabled. Otherwise they will be enabled for each bullet. Now, get the count from the monoflop and connect it to the bullet port. Then connect all B ports to the rigid body tags. Because of the animation is not starting yet, and no trigger actions performed, you see the dynamic tags are turned to off for each bullet. Let's start the animation and check the bullets one by one. Great. First bullet is fired. You can see the rigid body tag return to enable. All of them returns to enable and firing one by one. If you want to increase or decrease the bullet speed, adjust the initial linear velocities. Now, ready for the fun part. Now it's time for sound effects. Then we hit a few targets. Open the Xpresso editor and create two sound nodes. One for firing and the other for dry fire effect. You can find the necessary links for the sounds I used here in the descriptions. Open the play ports of sound nodes and try them. These are Boolean ports and we should make them on and off. How we do this? First, get the bullet count from the monoflop node and compare it with less than 9 method. If the result is less than 9, it means there is still a bullet in the cylinder. So the firing sound will be active. If the monoflop count is more than 8, it means the cylinder is empty. Then the click sound will be active. To turn sounds on or off, two conditions must be true or false at the same time. For this reason, we also include the trigger firing condition. Create two Boolean nodes, then select the IN operator. Then connect them to the compare nodes. Connect the firing value to the next ports. I apologize for the problems you see here. The screen recording program sometimes causes flickering and interruptions, and I have difficulty making port connections. I think I need a better graphics card. I was finally able to complete it. Everything seems fine for now. Let's see if the sounds will work as they should. Yes, it works. If we hear a click sound when the bullets run out, the process is complete. It's almost finished. Now let's try to hit the targets and complete the tutorial. Thank you for watching this somewhat complex tutorial. See you next time.